Okay, there's one more thing we want to say, and that's about our connection to the fact that the period of a sinusoidal function is 2 pi over b. Now, our function that we've got for the position of this oscillating mass is the amplitude times the cosine of omega t plus initial angle plus a constant on the outside if we want to shift the origin around. The b parameter in this trigonometric function is omega. So the period, in other words, the amount of time that it takes this function to repeat itself, capital T, is 2 pi over b, which is omega. So omega, if we cross multiply and solve, is 2 pi over the period. Now, 1 over the period of a thing, a period is cycles per second. Oh no, I'm sorry, I got that backwards. The period is seconds per cycle. How much time for one oscillation? If we do 1 over that, we're talking about cycles per second. We're counting how often this happens every second. That's a frequency. So you check your pulse, and maybe it's 80, and that's 80 beats per minute. So we could divide by 60 and talk about, a frequency. How many pulse beats per second? How many cycles per second? So the division by period here, division by period is like multiplication by the frequency. So this is 2 pi f. F is frequency. Multiply by 2 pi radians lets us talk about an angular frequency. F is how many cycles does this oscillating object make every second? And in order to undergo a cycle, the angle, the angular argument of our imaginary Platonic rotation has to undergo 2 pi radians of rotation, imaginary sort of Platonic rotation. Every cycle, every 1 cycle per second, we have to undergo 2 pi radians of imaginary rotation. So we're talking about how fast the argument of our function changes. The angular frequency, how many radians does it take for each cycle? And how many of those do we get per second? Okay. I told you that was short. That's all. That's all the lecture content for this week. If you have any questions, definitely please ask. There'll be one more kind of content video. It'll go with today or this week's lab activities, and that'll show up a little bit later in the day on Monday after I record it. But this week we do have a worksheet at least, and we'll go from there. Thanks, everybody.